This next presentation is something that I'm actually very quite interested in seeing myself. Cinera has been working with Microchip to solve a very big challenge in India within the electricity metering segment. There's a standard, if you all follow, the IS 16444. One of the requirements within the electricity metering, smart metering segment is addressing the IPv6 challenges. So what we're going to do is now be able to show you with LoRaWAN actually solving that problem. So our next speaker is Nimesh Yodurkar. I'm sorry if I butchered your name, sir. So he will be giving a demonstration and a presentation on behalf of Microchip for the smart electricity meters. The title of his presentation is LoRaWAN Enables Smart Electricity Meters in India. This is going to be really cool. I'm excited. Please, sir, it's all yours. Go forward, go back.
Okay, thanks. Hi, good evening, everyone. Thanks, Ali, for giving me a chance to present the new concept where the concept where we can able to do a lot of data transfer over LoRaWAN. So here about the market study says about the 25% of all Indian IoT will be covered by utility centers, where this overall use case comes in where to maintain the meter data, to see what could be the thefts and all those stuff. India is estimated around 130 million smart meters by 2020. We have seen few tenders flowing here and there, like smart meter tenders from ESCL that talk about 5.6 million tenders and all those stuff. It's not very small volume, it is in big volume, and it makes sense to have a LoRa when it talks about very large number of quantities. For very small, confined number of quantities, definitely we can use something else. But where there is very large number of quantities, then LoRa definitely makes sense. So use case benefits, meter to cache, where prepaid kind of stuff, to find out the thefts, to remove thefts, so that actually you all know the creating the energy makes a lot of pollution. So if we can able to solve those things, thefts and also losses, if we can manage that, we can definitely manage the pollution and all those things and can do a more sustainable planet. And most importantly, the use case can be a storage, storing the data. Right now, most of old use cases of meter, we are keeping the whole data or maximum 6 months of data or 10 months of data into a meter and all those stuff. So that can be removed and that can be put it into the IoT world. So why LoRaWAN? LoRaWAN, it's very easy. It's very, commissioning is very, I love LoRaWAN just because of commissioning purpose. I worked in Zigbee. I have pretty good experience in Bluetooth. Right now I'm also working few use cases in Wi-Fi. But why I like LoRa most of the time, LoRaWAN, because of its easiness of commissioning. There is no need of commissioning. Factory commissioning can be useful when you do a deployment. Another is, it's LoRaWAN always talk about IoT, isn't it? They talk about how data is going to reach to application server, how is data is, it's not going to reach to only a gateway, how that data is going to reach to IoT application server. So it's a true IoT network. So, and it gives us a more sustainable network. It's highly secure, as Diana told us. It's a two-way security, in and out, both-way security can be implemented on the LoRaWAN. With Microchip hardware security, definitely it will give us a more benefit and it becomes more secure. So what are the smart meter requirements? The first and most important requirement is the meter has to be IS 16444 compliant. What this means is it will have larger data requirements where large data will be going to be transferred from one end to another end. Then large number of tampers. India has very different kind of requirements and always large number of tampers to be reported to application server. Then there could be a requirement of taking the load survey of 6 months, 3 months, 2 months according to utility requirements. Then again, it became very large transactions. And billing data for India, it is quite different than any other country. I've seen that because KW, KVH, KVARH, and then 1, 2, 3, 4, 5, 6 different time zones requirement and all those stuff. So billing data will be always very huge. So as we see, as 16444 data packet size is very different and very huge. It can be divided into two parts. So the first part is command, which is going from your IS 16444 compliant HES system, which will be around to get instantaneous reading. It's just my analysis. 36 bytes of data from one end to meter, so that meter can reply into that. The billing data packet size is around 68 bytes. So none of data is very small, like 1 byte or 2 byte, where the LoRaWAN is basically started with. Whereas when meter replies, it will be 108 bytes of which has instantaneous data, and where billing data, if you see, it will be go up to maximum 232 bytes. So this is few of examples. I just put it and I just try to get it from meter, one of meter what we are demonstrating on the Sendra booth right now. And here you can see this data size is really huge. And how to transfer that data size is one of the difficulty on the LoRaWAN. So if you see in the LoRaWAN, we have SF 1251 bytes. On SF11, there will be a 51 bytes maximum payload. SF10 is again on 51 bytes. And now it's changed with SF9, SF8, and SF7, where you can see it is 122, 222, and again 222 bytes. So if I want to have a IS 16444 compliant network deployment, it has to be over here, isn't it? It has to be over here so that in one packet data transfer can be easily possible. So now network need to have a very high capacity network, number of gateways will be high, and overall cost of deployment is going to be really, really big. And that will definitely cost to your end customer, our end customer, or in the sense of ourselves also. So at least SF8 network should be there so that in one packet, all data, at least billing data, we can do a transfer. And another option is doing the fragmentation. So again, if you do a fragmentation, then to get that accurate fragmentation to be delivered on the application server, we need to use confirmed data transfer, isn't it? So in LoRaWAN, we have two types of data transfer. One is called as confirmed data transfer, and another one is unconfirmed data transfer. So whereas to reach the message accurately to application server, we need to have confirmed data transfer. So over here, the confirmed data transfer will definitely going to increase the overhead on a gateway. All confirmed data transfer will need to have acknowledgement from application server. And that will increase the overall load to a gateway to a network. So here, when we comes on a energy meter segment, we are talking about million piece in a one small location. It's not million piece in very large location. We are talking about 600, 700K in a very small place. Okay, there how many gateways, gateway can support the confirmed replies and all those things has to be taken care. So overall, if we do a very accurate data fragmentation, then the problem will be your number of gateways will definitely going to increase. So overall, with the traditional methodology, if you are going to do it, the cost of network is very high. So one possible solution could be doing it doing the IS16444 packet, I can say parser. Okay, it could be very simple. IS16444 parser could be inside a LoRaWAN device itself or module. Module could be a more Indian style of speaking, but module can do all those parsing inside a module. So over here, there could be a few pros and cons. So definitely, a benefit of that is then it becomes a very small packet which can do a transfer from meter to application server, whereas the cons will be it could be a very specific data payload that when transfer from your LoRaWAN device to application server. I can say that will be a customized packet and may not be, and it will be a different for different manufacturers. Then again, the backend system has to be different for different manufacturers. So it could be much more difficult to handle. Also, it requires high-end microcontrollers at LoRaWAN end devices, where memory requirement may be a very large, and there could be a requirement of data storage, because when the server is going to ask for a data, we may not be knowing of that. So those all will increase the overall end device price, and more importantly, not only price, it is all about the challenges to maintain those kind of customization for a very longer time. So here I'm coming with the solution number 2, where you can do a data transfer in a fragmentation format. So say a fragmented data comes to a LoRaWAN device, then the defragmentation and decryption and verification will be done by module itself, and it will be sent to meter. Similar way, meter will send that data to a module or any LoRa end device, and again fragmentation and encryption and signature will be done by module, and that fragmented data will be sent to network server. So next slide, we will talk about what is the benefit of fragmentation and all those stuff. So we have tested this with SAMR34 device, microchip SAMR34 device, and for signing and encryption decryption, we have used ECC 608, which is security device from a microchip. So benefit over here is the fragmentation methodology. What we are using right now for a demo purpose is FEC, which is called as forward error correction methodology, which has been discussed on FOTA implementation of LoRaWAN. So this is well known, and it is meant for transferring on a multicast. And a multicast says about it is unconfirmed message. So it can be used for unconfirmed. The advantage of FEC is even 20% or 30% of data loss, still autonomously we can generate entire packet itself. So this is one more very biggest advantage. Another advantage is we can keep the simple HES, which has been already approved or already proven with the IS16444. So this is what we have done. Right now, its demo is available on Senra booth, where the meter and LoRa module has been connected. And on the LoRaWAN module, we are using SAMR35J18A, and for security purpose, we are using ETCC 608 device. And for current demo, for fragmentation and defragmentation, we freeze up the ports that can be changed according to requirement itself. Okay, sorry. So the large data transfer we have shown in a demo right now, and we have tested this with 1024512 and 256 bytes of data for more than 1 month or so, and we've seen that there is no packet loss as such. And with ADR, too intelligent ADR, we can make sure this data size can be changed automatically because ADR will gives help to change the end payload as such. So demo is available on Sendra both. You can anytime come. I can show you how this fragmentation has been done and multiple packets has been transferred from device to network server. And even for few commands, network server does a fragmentation, and those fragmentation comes to a device, and a device can reply onto that particular command. So this, thanks a lot for giving me a chance to present.
So I didn't give Nimish a fair introduction because I couldn't get his bio in time. So I'm going to read it out just to give you the credit that you deserve. So Nimish works with Microchip for over 7 years. He has 15 plus years of strong experience in embedded designs and wireless designs, highly skilled in IoT protocols, embedded software, embedded Linux, device drivers, EDA, consumer electronics. He's got strong experiences in handling multiple wireless technologies like Zigbee, 6LoWPAN, Bluetooth, Wi-Fi, and of course LoRaWAN. Can you give me a quick explanation on how long this project has been ongoing for you on trying to solve this challenge with electricity meters and LoRaWAN?
Yeah, we are working since from last about 4 to 5 months now, and 1 month we kept it on continuously on a testing purpose so that we can able to understand how many packet loss it's happening. Because in energy meter and in LoRaWAN, each packet does make sense actually. So we have done that, and we have seen there is no packet loss at all.
That's fantastic. Well, thank you, and everyone, another round of applause. If you want to see the live demo, it's on the space, on the center table, actually. Thank you, sir.
Thank you. Thank you. Thanks.